Let's go ahead and take a look at a new truss problem with an extra component, a extra force pushing our bridge to the right as opposed to just a force pushing down. And that might seem a little scary, a little daunting at first, but as you'll see, it really doesn't change the problem all that much. So for example, step 1 is still the same. We're still going to solve for our angles first. So that's theta 1 here and theta 2 over here. So let's start with theta 1. Well, as you can see, we know our opposite and our adjacent. Well, you might not think you know the opposite, but this length over here is clearly just 5 feet. It's just dragged out, but it's still the same length. And our adjacent is right next to it, so we know our opposite and adjacent distance. That's tangent. So we use our inverse tangent since we're looking for the angle itself. And what is, okay, opposite goes on top. We put 5 on top. And then we put 3 on bottom, the inverse tangent of 5 over 3. To solve for that, what we do, we're going to go second tangent, and we'll say 5 over 3. And what do we get? We get an angle of about 59 degrees. Okay, so we say equals 59 degrees. And then theta 2 will be the exact same. Will still be opposite over adjacent, so we'll say inverse tangent of, well, what is our opposite? Well, it's still this length here, which is 5, and our adjacent to this angle is also 5, so we'll say 5 over 5. We plug that into our handy dandy calculator. We say inverse tangent of 5 over 5, and what do we get? We get 45 degrees.